Okay, let's try to finish this up. I hope to keep the 2 videos. It's going to go to 3. Maybe this third one will be short. Who knows? Get me talking on this stuff. I don't stop. Okay, so let me minimize myself. So where we left off is we're talking about Taylor's second attempt at examining her online computer-based modules to prevent smoking in adolescents. Her second attempt here compared the 8th and the 9th graders as pre-selected groups because of convenience. And we kind of explored how that kind of approach, that kind of design, does not control for a number of different common threats to internal validity. There are many possible alternative and plausible, the word I like to use in this context, alternative explanations for the pattern of results she might see. Okay, so even though one of those explanations is, of course, that the modules work, in this study design, we can't be certain. We have no level of certainty of that because of the many factors that could also be making this pattern appear, or causing this pattern to appear. So let's go on to the third design. In the third design, she adds another component to it, which is random assignment. In the first video, I talked about the power of random assignment to control for many factors about individuals, specifically to control for selection bias and then related kinds of interactions with selection bias. And so in this study, let's see how that plays out in terms of the results and the interpretation. Well, this is a randomized pre-test, post-test control group design. And in this case, instead of saying, well, I'm going to compare the 8th graders to the 9th graders, I'm going to mix them all together, and then I'm going to randomly assign them to experience the brochure, control condition, or the new modules, right? And remember that this random assignment procedure is effective at creating 2 groups that are essentially equal, and essentially equal on just about every, theoretically, every quality about these 2 groups should be equal under random assignment, with sufficient numbers. A little caveat there, but random assignment produces groups that are essentially equal at pretest. The idea being if they differ at post-test, the only explanation can be something related to the independent variable. The IV is the computer modules versus brochure. The DV is did you smoke in the last 2 weeks. Again, a pre-test, post-test design with computer modules, and again, I left it out in this slide. This is what happens when I copy slides instead of making new ones. Computer modules or brochures. So that's the comparison. The results are here, and this is unfortunately I have this left over from my previous slide. Again, I shouldn't copy slides. This is just the current modules. Ignore this 9th graders, and this is the new modules. This is not here. These are brochures. This is new modules, and these are the results. Again, this is the pattern you would hope to see if you were doing this study in the right way, doing it correctly, or doing it incorrectly. But it's the pattern you'd hope. Both groups start off at the same equal levels at pretest before anything has happened. One group gets, again, this should be brochures. The brochures group is kind of the control condition. You don't expect that to have much of an effect. They show a natural tendency, maybe a maturational tendency to attempt and try smoking, to explore, that sort of thing. But the new modules put a halt to that pattern. The new modules keep it low instead of it being equally high. The new modules show a big difference here at the end. And rates of smoking at post-test are much lower with those new computer-based modules than they were with the brochures, right? And so now the question is, with a study like this, and we found this pattern with the last study when the 8th and 9th graders were separate, but we said, well, there's lots of alternative explanations for this. Let's look at some of those explanations now in this context where there was random assignment to conditions, so that these groups have been essentially equalized across dimensions through the power of random assignment. Well, history is not an explanation for this, right? History happens to all these people. So a history effect would affect both these groups in the same manner, and history is estimated, but history is not a plausible explanation for why they differ. History would have to be different for half of the group that will receive random assignment to one condition than the other. And it just, it would have to be extraordinarily coincidental that half of the people who were randomly selected to be in one, randomly assigned to be in one group, would experience a different historical phenomenon than another. It's just not plausible. Yeah, you could say maybe aliens came down and attacked the experimental group or attacked the control group, made them smoke more. Yeah, we can think of a possibility, but it's not plausible. It's not reasonable. Selection is not an issue because random assignment controls for selection. It makes these groups equal. There's no selection bias for the groups. They're equal because of random assignment. So when they differ at the end, we got to figure out a reason why, and it's not because they were different at the beginning that they were different at the end. Selection doesn't make sense. It's not plausible. It's controlled. Selection by maturation, which was a big problem when it was 8th and 9th graders, is not plausible anymore because, number one, selection's been controlled, and maturation is estimated. Again, if this is the control group, we might say this is the natural maturational pattern, and then this pattern here is truncated. Well, what's the cause of that slowing of the maturational pattern? The cause is most likely the independent variable. The new modules are having that impact, right? Because there's different rates of growth here, or rates of exploration, that the modules are impacting differently than the brochures are. But that's still all evidence for our independent variable. We didn't talk about these in the context of the other examples, but this kind of randomized design with control groups, with random assignment and control groups, also eliminates testing as an explanation, right? The fact both groups took the pretest, both groups took the post-test. Any testing effect is equal in these conditions and can't explain why there's a difference here but not here. Instrumentation, likewise, is controlled in the sense that it should influence both these groups differently. They both had the same instruments at time 1 and at time 2. Well, not plausible, right? This pattern of results, combined with the knowledge that there was randomization, equalization here at pretest, makes instrumentation not plausible. Regression's not plausible in this case, in part because these groups weren't selected for extreme values, which is part of regression. But even so, even if they were, we'd expect these groups to be equal at the beginning, that they would experience regression or statistical regression at the same rates. But they don't. They don't. Regression, like history, like maturation, should affect both groups equally and not one group more than the other. Placebo effect, right? Same, one group, it's just not a plausible explanation anymore that one group had a placebo effect and not the other. Both had some sort of intervention, and what appears to be the difference here at the end is the nature of the intervention. Right, so now random assignment can control a lot of these things with controllers. It doesn't control everything. Some of them we still rely on other methods of control. So Hawthorne effect is still possible to the extent that one group received a lot more attention from the experimenter than the other, right? And I've cautioned some of you in your projects to make sure that you don't have one group do nothing and the other group interacts with the experimenters a lot, right? That can create a Hawthorne effect. One group is different because they got paid a lot more attention. They felt better about themselves than the other group who felt ignored, something like that. So Hawthorne is still possible, and you control that through other means, through how you design the study, through equalizing, making sure both groups have the same amount of attention. Diffusion is possible in this study to the extent that they may have talked to each other, but the fact that they were strikingly different at the end suggests that the interventions had very different effects, right? One resulted in much lower rates of smoking than the other. So if the groups had kind of equaled each other out because they were talking about each other or sharing the computer modules. You wouldn't expect a drastic difference here at the end. Finally, I just want to mention attrition really quickly. Attrition is something you have to examine at the end of the study and see whether it played a role. And what for attrition to be an alternative explanation, more folks, or for different reasons, folks need to drop out of one group than the other. And attrition is a special case of selection, but it's selection at the end. And what happens is groups that were equal at the beginning, because one group experiences a lot of dropouts, they're different at the end than the other group who didn't experience dropouts. So even though you equalize them at the beginning, because of dropping out of the study, the groups are not the same at the end. So attrition is something you kind of have to look at the end. Random assignment doesn't guarantee it. The only way to eliminate attrition is to make sure you have follow-up on 100% of your subjects, and or that both groups had about the same amount of attrition, and if it was relatively low, we tend to believe attrition is not a factor. Okay, so these examples I hope highlight several things. One is the utility of control groups. It's very useful to have control groups against which you can compare and estimate effects like history and maturation for the entire study. Random assignment as a powerful tool to control for things, and hopefully this helped illustrate the concept of internal validity. And one thing I think that's missing so far in this class is the need to think about internal validity in terms about explaining the results, thinking about the expected results you'd want to see, and then saying, well, what are possible alternative explanations for this? What are those plausible, other than the independent variable? And lastly, this example highlights another distinction. These examples do true experiments versus quasi-experiments. And in a stricter sense of what the book lists many things as quasi-experiments, but example 2, where you did something different with the 8th graders than the 9th graders, they were your two groups without random assignment, is really what a quasi-experiment is. And so this last slide here kind of illustrates what are the differences between an experiment or a true experiment and a quasi-experiment. An experiment is a research study where there's manipulation and control over the extraneous variables, typically using random assignment to condition to create groups that are equal at pretest. A quasi-experiment, in at least the more stricter sense of what a quasi-experiment is a research study where there is also manipulation, but less control over extraneous influences. You may have people at one site versus another that you're comparing, so it's not exactly the same research site, and there may be different influences at different sites. Or there's lack of random assignment. The people at one site differ from the people at another site or in a different classroom. So you can't be certain that the groups are equal at pretest before receiving the interventions. And so, again, comparing the 8th versus the 9th graders is a good example of the quasi-experimental nature of that second example. And so they're like experiments, but they don't have the same amount of control, and as such, they're more open to alternative explanations, and we're less certain, even given the results we want to see, that the true cause was the independent variable and not something else. So there you have it. Hopefully that'll help explain some of this and help people with the concept of internal validity, which is really difficult to get your heads around without some lecture involved. The book may not be very good at that. I may not be very good at it. We'll see. All right. Again, you know where to reach me if you have questions. We'll see you. Have a good weekend.